Hello friends, we were discussing about the different direct method of pressure measurement by using the following transducers such as resistance type, pressure voltage type, inductive type, capacitive type, carbon pile type, piezoelectric type, photoelectric and finally electromagnetic type. In the previous session what I have done is I have completed up to this portion. Up to this portion I have completed, and in the inductive portion we were discussing about LVDT. Let's get started the previous let me continue the previous session. That means let me start from the inductive type. Okay, major portion I have covered, only the LVDT portion is remaining. Let us go back to the particular session. Okay, so I'll be discussing about the pressure measurement by using LVDT. As you can able to see, we are applying the pressure externally. You have connected one bellows here. Bellows are directly linking with the particular shaft. And the movable core, suppose if the movable core is at the middle position, the differential voltage, let me call E1 and E2. That means the voltage across the first coil is E1, voltage across the secondary coil is E2, second coil is E2. So when the movable core is at the middle position, the difference between E1 and E2 will be absolutely zero. Okay, number one. The second case, if the movable core is towards at secondary coil 1, obviously what is the voltage? I will be getting E1 minus E2. Okay, I am able to get E1 minus E2. In the third case, if the movable core is nearby secondary coil 2, what might be the voltage? The voltage will be obviously E2 minus E1. It is sure. That means input is pressure. It is very true. Input will be the pressure. It's a non-electrical quantity. Output I am getting the voltage. So non-electrical quantity that is going to convert into electrical quantity. So this is the way you can make use of LVDT for the pressure measurement. Hope it is very clear to you. Likewise, you can go ahead with the RVDT also. RVDT stands for the rotary variable differential transducer. You can check the previous video. I have already prepared that particular video also. Now let's study about the reluctance type pressure transducer. First of all, you know reluctance. Reluctance S is directly related to L divided by mu into A, where mu is the permeability and L is the air gap and A is the area of cross section. So this is your gap length, air gap length, L. Let me call it as L. So in case you are applying the pressure from this end, what is going to happen? You are applying the pressure. If you are applying the pressure, the air gap comes down. It is very clear. Suppose if the air gap comes down, the reluctance value is also getting reduced. In parallel, what about the output voltage? So output voltage, there is a slight increase in the output voltage because reluctance has reduced now. So definitely you can get the high output voltage. So this is the way how to measure the pressure by using reluctance transducer. Input will be the pressure and output will be in terms of voltage. Okay. Now let me discuss about capacitive type pressure transducer. As you can able to see, there is a parallel plate capacitance. This is actually the plate 1, fixed plate, and you can see the variable plate or flexible plate, plate number 2. In between you have filled the dielectric medium. You are applying the pressure here, fluid pressure. You are applying the pressure. So definitely what is going to happen? The capacitance will be directly depending on the permittivity, then area of the parallel plates, then the distance between the plate. That means the distance between plate 1 and plate 2. Now what will happen? What happened, you know? Suppose if the dielectric constant, the value of dielectric constant is getting varied, that will be directly influencing the capacitance. Because with respect to the pressure, the dielectric constant will get changed. So that will be directly influencing on the capacitance. And also I would like to say, with respect to the application of pressure, the area of the plate may be getting changed. So area, if the plate area is getting changed, that will be directly depending on the capacitance. That is also true. And also one more thing I want to tell you, if the gap distance is getting varied, of course the capacitance will be varied. How the gap distance varied? With respect to the application of pressure. So pressure is a non-electrical quantity, the capacitance will be the electrical quantity. This is the way how to measure the pressure by using capacitive type pressure transducer. Next I wanted to discuss about carbon pile type pressure transducer. Here you can able to see we are applying the pressure here. There is a flexible lead wire. Then here you can see the carbon particle or carbon plates that will be influencing the resistance. with respect to the pressure, what is going to happen? The area may get reduced. So you know that resistance is inversely proportional to area, and the length of the flexible lead may get changed. So you know resistance is directly proportional to length. So with respect to the application of pressure, what is going to happen? The length and area will be getting changed. So because of that, the resistance will be getting varied. So input will be the pressure is the input, and the resistance will be the output. This is the way how carbon pile type pressure transducer gets operated. Next we will discuss about piezoelectric type material. So here we can use Rochelle salt or any other type of material. Here we are using the piezoelectric crystal like Rochelle salt, and we are applying the pressure. The changes in application of pressure will changes in the voltage across the crystal. So that's a simple working principle of piezoelectric transducer. Here you can able to observe the diagram. Okay, so diagram says that, okay, with respect to the pressure, what is going to happen? The piezoelectric crystal is getting activated. So based upon that, you are able to get the voltage. That voltage can be getting amplified with the help of any type of amplifier. This is the way how piezoelectric pressure transducer operates. I hope it's clear. Now we will discuss about photoelectric type pressure transducer. Here you can able to observe there is a pressure pot wherever you are going to apply the pressure, and there is a slit. There is a small window available. Apart from that, there is a light source, and we can say the photo tube. Okay. Now initially the entire light will be activating the photo tube, and you will be getting the voltage. Whenever you are applying the pressure, what is going to happen? The width of the window comes down. With respect to reduction of window width, the photo tube, the performance of the photo tube also getting reduced. Thereby output is getting reduced, output to voltage. That means if the pressure is high, the output to voltage comes down. So this principle is known as photoelectric type transducer. I hope this is very clear to you. Next I want to discuss about Bridgman gauge. Here you can see a fluid. There is a fluid area, kerosene fluid. With respect to the application of pressure, the kerosene fluid is getting varied. So that will be directly influencing this particular lead. The electrical property of this particular lead is getting changed by application of the pressure. So this type of arrangement is known as Bridgman gauge. Okay. So in this session we have discussed about different direct methods such as Bridgman gauge, photoelectric type pressure transducer, piezoelectric pressure transducer, then carbon pile type pressure transducer, capacitive type pressure transducer, reluctance type pressure transducer, inductive type pressure transducer, next pressure voltage transducer, resistance type pressure transducer. So in the coming session I am going to discuss about the direct method of measurement of pressure. If you are having any clarification regarding my presentation, kindly request you to put up in the comment box. In the previous session, I just started with the inductive type pressure transducer. Okay, so please recall whatever I discussed in the previous session, and definitely it will be helpful for writing the examination or interview purpose, or to understand the real meaning. Okay, so finally, thank you for your kind support. Once again, I am thanking you.